Welcome to this brief screencast on Chapter 3, Sections 5 and 6, basically branching. In Java, there are two branching control statements, the if statement and the switch statement. And those are sufficient to do all the different kinds of decision making that you need to do in Java. So the first branching statement is the if statement. It has the keyword if, and then parentheses. Inside the parentheses is a Boolean expression. And then after that, you have statement 1, else, statement 2. The else portion of the if statement is optional. So if the Boolean expression evaluates to true, we will do statement 1. Else, if the Boolean expression evaluates to false, we do statement 2. I personally prefer the second version of the if statement, where you have curly braces and then you can have a block of code in statements 1 and statements 2. Even if I'm only going to have a single statement, I would like the curly braces because I can much better see what's going on. And we'll talk about that very shortly. So, where does the else go with this particular if x is greater than 0? Then inside the if x is greater than 0, we say if y is greater than 0, we print out first case. Else, we print out the second case. So if you look at the indentation, it looks like the else should go with the x greater than 0. But unfortunately, Java doesn't do that. Java makes the else go with the nearest if you do not use curly braces. So if you want to have the else be part of the x greater than 0, you need to put curly braces. So now this is very clear that the x is greater than 0 is a block with an if statement in that block, close the block, and then the else statement is associated with the x is greater than 0. So if you use parentheses, open curly braces, it's much easier to see where the thing, or which part of the code it belongs to, because you're specifically saying this else block is part of the if x is greater than 0, not part of the if y is greater than 0. Much better to use parentheses everywhere. Multi-way branching is how we can say if more than one thing, so we can actually do three statements with multiple different Boolean expressions to divide up the way we do it. So only one of the statements will be executed in this if else statement. So if the Boolean expression 1 is true, we execute statement 1 and then we skip the whole else part, the first else part. If Boolean expression 1 is false, then we have to evaluate the second if statement here. So we have to say if Boolean expression 2, if that's true, then we do statement 2. If Boolean expression 2 is false, then we do statement 3. So we do expression 1 is true, we do statement 1. If expression 1 is false, we then evaluate expression 2. If it's true, we do statement 2. If it's false, we do statement 3. So we can generalize this multi-way branching to say if test 1, we do statement 1. If test 2, else if test 2, we do statement 2. Else if test 3, statement 3, ... Else if test n, we do statement n, and then we have our final else, so let's do statement n minus 1. And again, all these statements, you can have open curly braces, so we have multiple statements in the each of the statement blocks. And each test is evaluated at one after the other if the previous tests are false, right? So if test 1 is true, we're done. If test 2 is true, we're done. After evaluating test 1 to be false, test 2 is true, we're done. So if each one is false, we're going to keep evaluating them until we either test n is true and we do statement n, or everything was false and we do statement n plus 1. So to take a look at that from the flow of control point of view is if it's test 1 is true, we do statement 1, and if it's false, we do test 2, statement 2. So all the right-hand sides are falses. So we go down the right-hand side, and then eventually, if every test is false, we do the last statement n plus 1. And eventually, everything ends up at the exact same next statement that came after this big if-else-if statement. So one thing to say. So often if you have this big long chain of if else's, you may not actually want to do something in one of those blocks or in one of those cases. For example, if you're done, well, there's nothing to do except for if you're not done, then you want to print out we're not done. Well, how do we do that? Well, we could use the semicolon, which just says that we have a statement, and the semicolon all by itself is an empty statement. Or we can have an empty block, which is if done, open curly brace, close curly brace, we have an empty block, else we say we're not done. So this if statement does nothing if done is true. We execute an empty statement or we execute an empty block, which means we don't do anything, and we continue on our merry way. If done is false, we'll print out we're not done yet. Now, using the empty statements is dangerous. Statements using just a semicolon can be dangerous because take a look at this. So for int I equals 0, I is less than 10, I plus plus, semicolon. So this is our for loop. We're counting from 0 to 10, actually 0 to 9, and it looks like we want to print out hello 10 times. But the empty semicolon at the end of the for loop says the body of the for loop is nothing, and it only prints out hello once because we execute nothing 10 times, and then we execute system.println once. So very careful when you just use the empty statement. If you use curly braces instead of just statements, then it's obvious that you would have an open curly brace and a closed curly brace, and you would see that the system.println is not inside those braces, and it would not give you a false impression that we're going to print that out 10 times. So it's much better to use the curly braces than just the empty statement. So what's the next branching control structure that Java has? It's a switch statement. And what it is we have the keyword switch, we have an expression that is evaluated, open curly brace, and then the keyword case, and then a constant. So you actually have to have a constant, and a colon, and then some statements, break, case, constant 2, break, ... case, constant n, break. Optionally, you can have a default, and then statements in the default, and then with the end curly brace. So what we're doing is this can be much more efficient than the multi-way if, because when we evaluate the expression, we can jump directly to which of the constants, because we have to calculate a constant, is, and the break says jump out of the switch statement. So when we hit the break here, like in case 1, if it was constant 1 was the value of the expression, we hit break, we skip all the stuff down to the close curly brace, and we go to the next statement after the switch. Now notice in the default, we don't have a break because we don't need a break because we're going to fall out the bottom anyway. We could put a break there, but it's just sort of an extra step that's not necessary because the next thing is the close curly brace and we go on. So if you miss a break, for example, take out the break in case 1, I'll go to case 1, there's no break, I'll continue down until I hit a break to jump out of the switch statement. That's probably not what you intended, but it could be something you want to do. Very careful to be careful that you put your breaks in there unless you specifically know you don't want to do, you want to do more than one thing. So make sure you are very careful with putting your break statements in, because that jumps you out of the switch. Let's give an example of a switch. We're going to choose rock, paper, or scissors. And so we have the string computer move, and then we have a switch statement, and then we have an expression, and in this case we use the math random to pick a random number between 0 and 1. We multiply it by 3, and then we cast it, because that's a double, cast it to an int, so that will give us a 0, 1, or 2. And so here's our switch statement. The case 0, which is the constant 0, says we pick rock. We say break because we want to assign the computer move to rock. Case 1 is we choose paper. Case 2 we choose scissors. We break. We don't have a default statement here because we don't need one. And then we print out the choice. Unfortunately, this code does not work, and the reason it doesn't work is because the Java compiler cannot know that every possible choice is there. It thinks that maybe the expression could evaluate to something other than 1, 2, or 0, 1, or 2, and so it says the string computer move has not been initialized because it can't guarantee that it will be assigned in the switch statement. So this won't work. But we could fix this quite easily by changing that case 2 to be default. Now when the Java compiler looks at this, it can say, oh, if none of the cases that evaluate, I know I'm going to do default, so I know the string computer move is assigned something. So that will make it legal. So now you say, well, we're going to pick between 0, 1, and what happens if we pick 2? Well, it's not case 0, it's not case 1, so we do the default, which is when the cases are not chosen, we do the default. And so that will actually print out rock, paper, or scissors based upon the random number. So that will work. So it's almost always good to have a default case in your switch. It's just a generally good idea to have a default case in case the thing evaluates to not one of your choices. You want to do something generally, and so figure out what the best default case is. So that's the basics of branching in Java. We have if else, if else, and then finally the switch statement. Thank you much for your attention.